Okay, so we're going to look at the practical application of calculus. So the question reads, a rocket fires vertically upwards after t seconds. Its height h is given by the formula. So t represents seconds, okay, and this would be time here, okay, the horizontal axis or the x-axis. Its height h is given in meters. That'll be the y-axis or the vertical axis. So I'm just going to write that in here. Time, you can see it starts at 0, and height. So we can see that this rocket is fired into the air. It reaches a height of 500 meters and it drops. Okay, and I know from making that graph that the whole process took 20 seconds. Okay, 20 seconds. So we're going to take our formula, h equals 100t minus 5t squared. So we know this is the relationship between the height and the time. Over time the height increases, stops, and then goes down. Part 1 asks the height of the rocket after 2 seconds. So h equals 10 2 seconds for time minus 5 times 2 squared. We can put that into our calculator. If you're calculating in your head, be careful with 5 times 2 squared. Indices come before multiplication, so 2 squared is 4, 5 fours are 20. 100 times 2 is 200. 200 minus 20 is 180. So let's see what we've just calculated. What we've just found is that after 2 seconds, the height is 180 meters. It's the height of the rocket. Okay, part 2. The velocity of the rocket after 3 seconds. So remember, when we differentiate, we're finding the rate of change, okay? It's a word maybe we haven't used in a while, the rate of change. So the velocity here is the rate of change. So we're going to differentiate dh dt because we're talking about height and time. Okay, the change in height with respect to time equals 100t becomes 100 minus the power comes down, 2 times 5 is 10 times t, and we drop that by 1, 2 minus 1, so it's 10t. Now the question asks us after 3 seconds, so that means t equals 3. So now it'll be 100 minus 10 times 3, which is equal to 70. Velocity, we're talking about speed. So speed will be measured in distance versus time. So 70 meters is our distance, or height in this case, and time is measured in seconds. So it'll be 70 meters per second after 3 seconds. Okay, because remember, it's a curve and the speed isn't constant. Part 3. After how many seconds the rocket is momentarily at rest? So looking at the graph again, the rocket's fired up, it reaches a high point of 500 meters. It's momentarily at rest then. Okay, you could take a guess when you know that the whole process takes 20 seconds. Okay, it's probably going to take half the time to get up, half the time to come down. Let's calculate that. So we know that the slope of the tangent when it's 0, it's a maximum or minimum turning point. In this case, it's a maximum turning point. So we need to let dh dt equal to 0. So that means 100 minus 10t equals 0. So we're going to add 10t to both sides, and we get 100 equals 10t. We divide both sides by 10, and we get t equals 10. So that tells us that after 10 seconds, the rocket is momentarily at rest. Okay, I'm going to highlight that on the graph. Remember, you won't have the graph in a question, and it'd probably take you a long time to do a graph like that, but there's the point. Okay, that's after 10 seconds. Part 4 asks the maximum height reached by the rocket. Okay, we already know the answer is 500, but we need to do it mathematically and prove it. So the maximum height comes when it's at rest after 10 seconds. So we go back to the original formula. Height equals 100t minus 5t squared. We know it's after 10 seconds, so we're going to sub in 10. So the height is 500. So 10 seconds, 500 meters. That's it.